wanted to give you an example that hopefully will allow you to understand impulse, but also to understand the implications of impulse and really conceptually what it means and how to actually change the amount of force and the amount of time that you have on a collision. So we have this car that's traveling and it's going to come to a stop after it hits a tree. Not the most glorious scenario, but it will get the job done for really what I'm trying to show you here. So the first question I have here is then what is the car's change in momentum? Well, we know that the change in momentum is just equal to the mass times the change in velocity. So since I know what the mass is, I know the change in velocity, I can just plug that in. So delta P is going to equal the mass, which is 800 kilograms, times the change in velocity. Well, it's traveling initially at 25 meters per second. It's coming to a stop. So we had a negative 25 meter per second change in the velocity. So that gives us an overall change in momentum. So 800 times negative 25. So that's negative 20,000 kilograms meters per second. So that means that the momentum of the car is going to drop, which makes sense. It's coming to a stop. Part B is kind of the interesting first part of this, and that's what does that really mean if we have a change in momentum of 20,000 kilograms meters per second? Well, let's just say in this case that the time of the impact is 1 second. We know that if we're looking at impulse, the change in momentum is equal to force times the time of the impact. So if I wanted to figure out the force, I already know the change in momentum from part A. I can use the time of impact then to figure out the force. So if I plug in what I have negative 20,000 kilograms meters per second equals the force times 0.1 seconds. So if I figure out what force then is applied to cause this to occur, I get negative 200,000 newtons. So it's negative because it's pushing against the car. So that makes sense. The direction is going to be against the car. 200,000 newtons, that's a pretty good force. That's a pretty significant amount of force. So in part C, what if the impact is 0.3 seconds? So we're talking about a longer time of impact. So this collision is lasting a longer period of time. So again, we know that impulse, change momentum equals force times the time of the impact. So if I plug in my negative 20,000 kilograms meters per second that I got from part A, don't know what the force, but now the time is 0.3 seconds. I take that 20,000 divided by 0.3 and I get a negative 66,666.667 newtons. So this is what I wanted to point out. It's kind of an interesting occurrence. And that's when you have an increased time of impact. The increased time of impact causes the force to go down. There's an inverse relationship between the force and the time of the impact. Because with our collisions, we're pretty much talking about a set delta P value. So the only things that are really going to change are the force and the time of the impact. So the greater the time of the impact, the lower the force is going to be. Now, I think for a lot of people that doesn't make a lot of sense, because if you're talking about getting in a collision, you want to be in a collision, and I think a lot of people tend to want to be in a collision that doesn't seem as severe. And I think that more people tend to associate, well, there's less time of impact, so that means it's not as severe of a collision. The opposite's actually true. The longer you can have the time of the impact, the better it's going to be for you because the less amount of force. That's where airbags come in. That's where seat belts actually come in. That's where bumpers come in. The whole point of airbags and seat belts and bumpers is to increase the time of the collision, specifically with you, with the seat belts and the airbags. It means that you are slowing down over a longer period of time. And since you're slowing down over a longer period of time, it means that the force acting on you is going to go down. So the whole point of those seatbelts and the airbags are to protect you. The bumper is trying to reduce the amount of force that's acting on the car because it's slowing down the car then in an increased amount of time. So it's kind of an interesting application because impulse is used all the time. And these calculations are used all the time by a lot of different industries trying to make things safer for you. So make sure you understand that there is that inverse relationship between the time of the impact and the force.